Question number 7 also includes a component about the confidence interval. Now, in question number 7 specifically, and in contrast to question number 8, question number 7 is asking about the distribution of means, so that's our statistic, and we're doing so using a two-tailed hypothesis test, two tails. That combination of things, so it is a distribution or a question about the distribution of means as our statistic, and a two-tailed test. Both of those have to be in place in order to use the confidence interval in order to reject or fail to reject the null hypothesis. So we can only use the confidence interval in hypothesis testing if it is a test of the means and it is a two-tailed test. In question number 8, for instance, we are still asking a question about the distribution of means, but it is a one-tailed test. Now, we can still calculate a confidence interval for question number 8, but that confidence interval will still be based on two tails. That is how we calculate confidence intervals. But our null hypothesis will be rejected or failed to reject using a one-tailed test. So that disparity, or confidence interval based on two tails, but a hypothesis test on one tail, means that we cannot use the confidence interval for question number 8. But we can on question number 7, so we're going to do that. So I've redrawn the curve because I think it's a little easier to explain confidence intervals this way. The red curve is still a distribution of means, but the line I've dropped down the middle is the sample mean in this case. We still draw the components that we identified previously. We have this purple region, which is associated with the confidence level, and the cutoff of that purple region is defined using the critical values. So before that was 2 point something or other in standard error units. So we still are measuring things in standard errors from a mean. In this case, it happens to be the sample mean. And that still leaves us with a rejection region out here. So this is 5% and this is 5% for a total of 1%, or 1 minus the confidence level. That equals the significance level. Significance level is alpha, which is 0.1. The new thing that we're adding here is this guy. It is the extent of the purple values. Now the critical values were measured in standard error units. The confidence interval, in contrast, is a distance measure in original units. So whatever units the sample mean is in this case it's megatons CO2 per year, our confidence interval is also megatons per CO2 per year. So that lower bound will be a number, and the upper bound will be a number, again, in original units. So that x bar, the sample mean was 167. So the lower bound is going to be somewhere kind of around 167. The upper bound will be 167. Maybe this is 130 and this is 230. So it will decide exactly how close it has to be, but it's in those same kind of units. It's not 2.3 or minus 2.3. If you notice, the limits of the confidence interval match the critical value. That is very much on purpose. That is how the confidence interval gets defined. Our critical value is in standard error units, so we are going to take that critical value and convert it to original data units, and that'll be the lower bound. Now we take the critical value up here in standard error units, convert it to original data units, same thing as x bar, and it gives us our upper bound. Ultimately, once we do that, we're still going to see whether or not our value of interest, in this case the population mean, falls within our rejection region. So in the case of t-scores, let's see, I don't think I want a red pen, purple, blue, green. Wow, I've used all my colors so far. Maybe we'll use a dark purple this time. So when we looked at the critical value, which is in, again, standard error units, if our data as a t-score fell in the rejection region. So if our data as a t-score was more extreme than our critical value, it fell in our rejection region and we rejected the null hypothesis. Now, if our value of interest, the long-term mean, falls over here again, but in original data units, so we're still looking, is it more extreme than this boundary? If our value of interest, our mu, is greater than our upper bound, we're going to reject the null hypothesis. Same exact interpretation. And similarly, if our value of interest, the population mean in this case, falls less than the critical value in standard error units, or, this is the way we do it with confidence intervals, or if our value of interest, the population mean, is lower than the lower bound of the confidence interval in original data units, then it still falls in here in the rejection region, and we reject the null hypothesis. So that's the theory. Really, confidence intervals are the critical values converted into original data units. That's probably the best way to think about it. So if we look at how to do this math-wise, we take our mean, the value here in the middle, and we need the critical value, so everything's based on the critical values, which we've calculated above. And then we have to convert the critical values into original data units. So we do that using the standard error. So the critical values were originally in units of standard error, so we will multiply by the standard error, and that gets our critical value into original data units. So we'll take our sample mean, and we will go plus and minus. In this case, I have a minus, but you'll do both. You'll add the critical value times the standard error, so the critical value converted into original data units, and add that to the mean, and that'll be this one. And we'll take our sample mean, and we'll subtract the critical value converted into original data units, and that will be the lower bound. And so again, our confidence interval will have two numbers, the lower bound and the upper bound, both in original data units. That is the confidence interval, and then again, because this is a two-tailed test on the mean, we can use the confidence interval to also do the hypothesis test. Our picture here looks exactly like it does here, so everything should match up in the end. We see whether or not our value of interest, our population mean of 211, falls within this range. And in this particular case, our confidence interval, so our lower bound, was 144. That should be a 4. And the upper bound here looks like 190. Wow. So that's that guy there. Our 211 is over here somewhere. So it is greater than the upper bound. It falls within the rejection region that is identified by the critical value times the standard error, so the critical value converted into original data units. So our population mean is greater than that. It is more extreme, so we reject the null hypothesis. It's all, again, the same curves based on the same values. Everything's based on this kind of critical value. So all three of these, critical value compared to t-score, p-value compared to significance level, which is alpha, or the population mean compared to the confidence interval. All three of those have to give you the same answer because it is a two-tailed test. I'll reiterate just one more time, like in question 8, when we don't have a two-tailed test, we cannot use this. We can calculate it, but we cannot use that as part of a hypothesis test. The answers we get from it won't make sense.